There are a lot of different kinds of research that have been done on the station in 2013 and every other year going back. But there are a couple of highlights that we want to look ahead to, things that are coming up this year. You mentioned deployables, stuff that we're going to put into orbit from the space station this year.
That's right. You know, there's a set of different standards now for small microsatellites and CubeSats. Some of them are as small as a coffee cup. Some of them are, you know, a little bit bigger, but still very small. And there are great technologies that can be tested that way, ways of looking at weather, ways of looking at the space environment, but they're launch limited. They're always looking for a way to piggyback on some satellite launch somewhere. And there's a whole queue of CubeSats waiting for launch opportunities. So our Japanese colleagues developed a larger CubeSat deployer we call the JSOD, and that has flown successfully to the space station this year. Then there's another set of deployers that was developed by the NanoRacks Corporation for these very small CubeSats. It can deploy up to 30 small CubeSats all at once. And we have a full slate of organizations, both technology companies, universities, education organizations, the National Science Foundation, that are interested in flying these deployables. So one of the big changes in the coming years, we're going to see dozens of these being deployed at different points in time from the airlock in the GEM, the Kibo Exposed Facility.
And these will be things that will be put out, they're not retrieved. What kind of research is going on inside these cubes that are flying away?
So some of them are technology demonstrations to do things like look at how, or prove how you might use these little satellites to inspect spacecraft, make changes, even potentially repair spacecraft someday. Others of them are looking at the space environment itself, and as they re-enter, they take information and they use ham radio frequencies to send data back to Earth as they're re-entering and provide extra information. Others are looking at the plasma environment or looking at other aspects of the space environment as they move along. And then some are just testing communications or even formation flying algorithms. Wow. So if you can release a number of CubeSats and they all disperse out together and can maintain themselves in a nice location, you get the impact of a larger satellite, but with the mass and so forth of the small satellites.
Interesting.
It's a great area for new technologies.
A thing that has been done on space station for many years are a variety of protein crystal growth experiments, but there's some new ones that we're looking forward to in 2014, right?
Right. You know, NASA did a lot of protein crystal growth early in the space station, and then we had a hiatus because we did some retooling of our portfolio and it wasn't seeming very relevant to exploration. And now with the National Lab designation of the International Space Station, commercial users, other government agencies like the NIH that are trying to get protein structures have the opportunity to come back to the space station and use that as an environment to get structural information about proteins and other biological molecules. So we'll have a set of experiments flying on SpaceX 3 coming up very soon. And those will be the first kind of comprehensive set of experiments really designed to show whether or not space gives you a complete advantage across a wide variety of types of proteins. And so that's a really exciting scientific study, because all of the other studies, you know, sometimes we'll get a good protein crystal back, sometimes we won't, and it's kind of controversial maybe whether or not every protein should go to space, for example. Right. So this is really going to help us put that scientific question to bed. Also, 10% of the samples are flying in that experiment on behalf of specific partners on the ground, pharmaceutical companies and NIH in particular. They have a biomolecular structure institute, and there are a bunch of proteins out there that we know are important in disease and we don't have a structure for. Yeah. And so that play back and forth between advancing the state of the science and also really providing an opening for these kinds of users to get access to space if it turns out to be a useful way of getting structures is a really important advance for 2014.
Looking ahead in the year, there's also some new biological research that's going to involve the use of rodents. What are we looking at there?
Yeah, so we had a decadal survey that the National Academies of Science did in 2011, and they looked at all the things that we could do in a microgravity environment and made recommendations. And one of their top recommendations was to really take advantage of that effect of floating in space on the body. We needed to have a capability to do significant studies in rodents. And so we've turned on that capability. During assembly, we had some rodent flights. Those rodent flights have been directly connected to drugs that have come to market. So we know that you really can learn things using rodents as a model There are things you can do with rodents as a model you definitely would not do with the crew as a subject in a medical experiment. And you can really get to that mechanism, understand what gene is turning on to cause what process, and can this drug stop it? And that's the kind of research that will be going on. Of course, you know, we've only flown relatively small numbers of animals in space before, and so there are some great opportunities for fundamental discovery as well.
These are just a couple of examples of new things, but another thing that's going to be happening in 2014 is that you and your staff are going to be working on the science program for the crew that is going up there for a full year, the year-long crew. What kind of things are you going to try to use that crew's experience to take advantage of?
Yeah, the one-year expedition has been a really amazing collaboration between U.S. scientists and our Russian colleagues, because we've been looking at all of the different risks to the human body from being in space, coming up with what list of that is the most important that everyone knows we really need to solve before we leave low Earth orbit and go on to a future destination. And then we're going to be targeting experiments that are focused on those to make sure that the things we've learned from studying crews that are up for about 6 months, that there's no surprises, no gotchas if you extend that out to 1 year. We'll be looking at bone loss, we'll be looking at neurovestibular balance disorders, we'll be definitely looking at the vision impacts and the loss of vision that some astronauts are experiencing, and it will be done in a joint medical program between the US and Russia for the astronaut and the cosmonaut to participate in.
Very exciting stuff to look forward to in the coming year.
Yeah, it'll probably be early in the year that we'll finally get the final selection of all the experiments, and the crew members will have had their informed consent and agreed to participate, and then we'll have a big announcement of what those experiments are going to be.
Things that we're looking forward to on the International Space Station Science, looking ahead to 2014. Space Station Chief Scientist Julie Robinson, thank you.
Thanks.